Good afternoon. Our main story today affects us all. How do we keep everyone's feet dry in the face of sea level rise and climate change? For centuries, the Dutch have been keeping the North Sea at bay by constructing dikes and dams. However, today, the Netherlands' main defense against coastal flooding comes from having wide beaches and strong, healthy dunes. These naturally erode during storms, serving as a protective buffer. To maintain that protection, the coast is regularly supplied with sand, suppleties or nourishments. For the past 35 years, these nourishments have built up the coast, but is that still the right strategy? How effective are they? And how do they affect the environment? To answer these questions, let's speak to our experts in the field, beginning with Dr. Natasha Panozzo from TU Delft.
Yes, we can get insight into the effectiveness of nourishment projects, Stuart, by predicting the trajectory of sand. Here in the Wadden Sea, every sand grain has a unique journey. The journey starts where a sand grain is picked up by water, and it ends somewhere else, where it gets deposited. Between the beginning and the end of its journey, a grain travels along the coastline and can take many different routes. Its route can change based on how high the water level is during the grain's journey, how many storms hit the grain while it's traveling, whether it encounters obstacles on its way, and so on. Predicting where sand grains will end up is necessary to evaluate whether nourishment projects will be effective and sustainable. But how can we predict sand grains' routes by only knowing where their journey starts? With the help of fancy mathematics, we built a computer model that can predict what could be the journey of a sand grain. If we feed the model with all the information about the different factors that might influence the journey, the computer model can help us predict with good level of accuracy where the sand grain might end up. Using our computer model, we can therefore inform how to design effective and sustainable nourishment projects.
Thanks, Natasha. So the models that we use are based on the latest science, but to go from theory to practice, we're going to need to test them on real-world data. Our next correspondent, Annemartje de Boer from Wageningen University, has a great new idea for adding one of the missing pieces of our puzzle.
Yes, that is why we are here in our luminescence laboratory in Wageningen. Ships go out onto the North Sea to mine sand and tactically place it to reinforce our coast. Natasha, her computer models predict the future journey of sand placed in the tidal inlet of Ameland. But we do not know what happens with the sand and if it's actually successfully strengthening our coastline. However, we can determine when sand last saw light. Did you know that sand grains have stored little light pulses in them, and that these light pulses can tell us about the origin of the sand because they build up when the sand is stirred in a dark place? We are here in a dark laboratory in Wageningen. When sand grains are exposed to light or heat, they emit a little light pulse, which we can measure and is called luminescence. With this technology, we can potentially distinguish between the sand grains dropped by the ship and the sand grains that were already present. I'm going to show you how this looks like. The sand grains are giving light and are telling us about their sediment transport history. Adding another piece to the puzzle. Back to you, Stuart.
Thanks, Annemartje. With this knowledge, we can better understand where sand goes when it's placed on the coast. But what sort of impact does that sand have on the ecosystem? How does it affect vulnerable habitats like the Wadden Sea? We now turn to our ecological expert, Tjitske Kooistra from NEOS.
I'm standing here at the Wadden Sea, a globally unique nature area. Small seafloor animals are an essential part of this ecosystem because they provide food for the fish and millions of migratory birds that depend on this area. These seafloor animals, such as worms, clams and shrimp, depend a lot on the sediment that they live in. Some like it muddy, like this clam, while others prefer sand. We saw that many animals find the sea bottom in our research area, the Ameland Inlet, a bit too sandy. That is why we should keep an eye on if the seafloor sediment changes when we nourish the coast with sand. But not only do animals depend on the sediment they live in, they can also modify the sand themselves. For instance, empty shells can cover the sea bottom and limit the amount of sand that is being transported. Also, animals that live in the seafloor can mix the sediment by moving around. The more we know about how much these small animals influence sand movement, the better we can predict with our computer models where the sand goes, adding another piece to the puzzle.
Thanks, Chitska. In summary, computer models and field measurements help us to understand how nourished sand moves along the coast, from the scale of the smallest sand grain right up to the entire Wadden Sea. This knowledge helps us to better predict the impacts that such policies will have on our environment. These first steps pave the way for many future developments, helping to keep everyone's feet dry for a long time to come.